We're going to now do example 1b, and the purpose of this example is to focus on the constraints and manually graph the constraints and identify the feasible region and the feasible solutions. So here we have an example. Our objective function is maximize profits. Now I haven't clarified what the profits are because we're not focusing on our objective function. We're focusing on graphing out the constraints. So we have 3 constraints. All right, so what we want to be able to do is to rewrite these constraints and solve for x2. So I'm going to rewrite all 3 of these. The first constraint, which will have our blue constraint, is x2 is less than or equal to 150 minus x1. Our next constraint, which we'll call our red constraint, is going to be x2 is less than or equal to 3 divided by 420 which is 140 minus 2/3 x1. I just solve for x2 and bring everything else to the right. The next constraint, we'll have this be the black constraint, is x2 is less than or equal to 210 minus 3/2 x1. So those are our 3 constraints. Now we want to be able to graph out all 3 of these constraints. So we'll try to use a ruler to make the lines at least somewhat straight. So x2 is our y-axis, x1 is our x-axis. So we want to graph all 3 of these out. So let's start with the first one. The first one goes from 150 to 150. The way I know this is if x1 is 0, x2 is 150. If x2 is 0, x1 is 150. So that's our blue constraint. The red constraint starts at 140, and it's going to go, now if x2 is 0, we need to solve for that. So 140 times 3 divided by 2 is 210. So it's going to start at 140 and come out to 210. Now our last constraint, our black constraint, is going to start at 210 and come to 140. So now I've graphed all 3 constraints. And now I need to identify the feasible region. So the feasible region is such that x2 is less than or equal to the blue line, as well as the red line, as well as the black line. So here, on this red line here, is where we're less than the red line and the blue and black. But once we get to this kink, it's now going to be along the blue line, and now it's going to be along the black line. So this area here is our feasible region, including this kinked line that we just drew. Now we want to ask, what are the feasible solutions? Well, the extreme point theorem tells us there are 4 possible solutions. The 2 corners, as well as the 2 inner corners, or the 2 kinks. These are the possible solutions. Well, how do we solve these? What is the x2 and x1 allocations that satisfy this? Well, this point right here is simply x1 equals 0 and x2 equals 140. Or we could rewrite that as 0, 140. So we produce no units of x1 and only produce x2. That's a possible solution. This line right here is also a possible solution, where we produce 140 units of x1 and no units of x2. Well, this right here, well, this possible solution is where the blue line equals the red line. So here's our blue, here's our red. We just set those constraints equal to each other. So it's where 150 minus x1 equals 140 minus 2/3 x1. Now we just solve for x1. So we get 10 equals 1/3 x1. x1 equals 30. So that means this value of x1 is 30. We just plug it into the blue or the red line to find out what it is. Well, the blue line's easy. Plug in 30 for x1, and 150 minus 30, x2 is 120. So another possible solution, let's write the possible solutions here. All right, one is 0, 140. The other is 140, 0. Now we have 30, 120. Now the last possible solution is this one right here. That's where the black line equals the blue line. So the blue line is 150 minus x1. The black line is 210 minus 3/2 x1. So I subtract off 150 to this side. So I get 60 is equal to, add 3/2, so I get 1/2 x1. x1 is 120. So this x1 is 120. Now I plug it back into the black or the blue. Let's plug it into the blue because that's the easiest. x2 then is 30. So the other possible solution is 120, 30. These here are our possible solutions to solve for this.